Thanks for joining the webcast to learn how to accelerate your application deployment with VMware Cloud Management Platform. My name is Taka Uenishi, Product Line Marketing Manager of the Cloud Management business here at VMware. I'm joined today with Jad El-Zain, our distinguished Principal Architect, who will be demonstrating how to use the new Unified Blueprint model and design canvas in the recently announced vRealize Automation 7.0. Before we deep dive into the demonstration, I'll talk a little bit about the background and an overview on the VMware approach to set the context. And by the way, if you have any questions, feel free to put it in the chat window. We can answer your questions as we proceed along the way. Thanks. So what is top of mind for many CIOs and IT executives today? Through our conversations with our customers, we keep hearing a common theme around the need for agility. In today's cloud mobile era, consumers are now used to speedy, on-demand delivery of goods and services, with some of the newer businesses even delivering in just minutes of lead time. And so in this competitive marketplace, IT supporting these businesses must be able to meet these same demands. For example, are you being asked to support very rapid deployment of applications, maybe provide infrastructure services on demand, or even scale your resources dynamically based on the needs of applications? To help IT address this demand for delivering faster time to market, VMware provides an approach called App and Infrastructure Delivery Automation. This is one of the 6 IT outcomes that VMware can help with. VMware's IT outcomes are key enterprise-scale initiatives that quickly and cost-effectively drive business results without compromising security, control, or choice. They support the top priority initiatives for CIOs and impact key business metrics. By focusing on outcomes, it ensures your IT capabilities are aligned to business needs. So let's double-click into this third IT outcome that focuses on applications. Applications? You might be wondering, but wait, you're VMware, you're about infrastructure. Well, yes and no. Applications are the engine that enable the business to deliver services and capture new market opportunities. At the end of the day, it's all about the applications. In order to deliver new or existing applications to users instantly, anywhere, anytime from any device, the enterprise needs to be able to quickly build, deliver, and manage those applications. And the App and Infrastructure Delivery Automation approach streamlines this process. There are 3 stages to this IT outcome. Stage 1 focuses on enabling infrastructure and operations teams to automate the delivery of infrastructure services for application teams. And once you have the foundation for IaaS, Stage 2 enables you to automate the delivery of application and middleware services so that application teams can accelerate the deployment of integrated multi-tier apps. And finally, Stage 3 enables DevOps teams to streamline and automate the software delivery process to accelerate application releases. So while an IaaS strategy is critical for delivering infrastructure, it actually only solves a fraction of your business agility problem. In order to gain true agility, it's essential to establish an integrated end-to-end IT service lifecycle management. In this presentation, we're going to focus on Stage 2. So why is automating application services and middleware important? Current processes require IT to author individual machines and configure them together as working applications with all the appropriate dependencies, microservices, networking, storage, and security. But at most enterprises, this still takes months or multiple weeks, even those that are heavily leveraging virtualization and associated management tools. Why? Well, traditional operating models are based on the coordination between multiple teams, which involves the handoff of tasks, resulting in wait time. So as the enterprise grows and you have simultaneously process and explosive growth of requests, this can compound quickly. And on top of this, you must repeat this process multiple times across environments. A better approach is a policy-based automated delivery process by using blueprints that models and streamlines the process, eliminating wait time. Using blueprints enables enterprises to help manage workloads across dev, test, and production environments in hybrid cloud and heterogeneous environments, accelerating the delivery of infrastructure and applications. This enables you to install, configure, test, and deploy databases, middleware, and other application components inside the infrastructure services. Also rapidly provision consistent environments to facilitate the release process, and apply changes to applications continuously across your dev, integration, test, release, staging, and production environments. By reusing application blueprints and update profiles, It helps to overcome issues with manual configurations that lead to inconsistencies and errors, resulting in additional work, not to mention across environments. In addition, it helps reduce the risk of human errors from additional changes to the databases, middleware, and application components. VMware helps enterprises execute this by offering a cloud management platform, or CMP, that provides automation capabilities that vertically integrates infrastructure services, application deployment, and the downstream application release process. This CMP is actually the key control layer for the software-defined data center. At VMware, we define a CMP as a combination of automation, business, and operations, and it takes an integrated platform approach that enables IT to take operational insight combining with financial insight so that they can make optimal decisions around sourcing and workload placement and establish demand management. We believe a CMP should offer comprehensive day 0, 1, and day 2 operational capabilities. The CMP helps to automate the entire IT services lifecycle, defining the tenants and user groups, creating reservations, policies, blueprints, offering self-service, metering the consumption, monitoring the health, capacity, performance, and rebalancing the infrastructure to really optimize your resources. So we'll be looking specifically into Step 2, where Jad is going to demonstrate how to use the new unified blueprint model and design canvas. But before we go into the demo, let's take a quick look at the journey of one of our customers, Choice Hotels. Choice Hotels recently migrated its corporate data center to a VMware software-defined data center architecture. That facility is now about 80% virtualized, with approximately 1,600 virtual machines supporting the organization's production and development environments. Originally, IT had issues meeting the needs of more than 200 developers who write applications used by customers, employees, and franchisees. One of the main challenges was the long fulfillment cycles for application infrastructure needed by the dev teams. So Choice Hotels' central IT group, they leveraged VMware vRealize Suite to automate infrastructure provisioning. Developers can now provision resources on demand via a self-service portal, slashing delivery times for new business applications. They were able to slash application infrastructure provisioning from 4 to 6 weeks down to 30 minutes. It's also accelerated the delivery of new management applications to business users. Now developers can stand up an application middleware stack in less than 30 minutes, taking the infrastructure team out of the loop. The dev teams no longer see the infrastructure teams as a roadblock. And now they're looking further into platform as a service and building multi-machine and tiered application blueprints to further accelerate the application deployment process. So what potential benefits can you expect from Stage 2? Actually, Forrester conducted a study on the benefits of automating application deployment. The study presents an independent, objective view of the benefits compared to the processes that companies were using prior to deploying a VMware CMP solution. Forrester surveyed some advanced companies who had deployed VMware CMP to accelerate their application delivery. What they discovered was that on average, customers reduced application deployment times from 3 to 4 weeks to just under 1 day. This improvement in service delivery times made their development teams 25% more productive, allowing them to release new software functionality faster. The CMP solution also helped them avoid additional hardware purchases by eliminating over-provisioning and cleaning up and reusing idle resources. Now, just to be clear, the economic model developed by Forrester doesn't include any business benefits related to competitive advantage and new business opportunity that resulted from delivering new functionality to market faster, because that's fairly subjective and difficult to quantify. However, using just the productivity improvements and hardware savings resulted in a 3-year ROI of 243% with a break-even of less than 6 months. Okay, well, I think you've had enough context now. So now let's see what's new in vRealize Automation 7.0, a key component of the CMP solution, and see how it actually works. So without further ado, let me hand it over to Jad. Jad?
Okay, thanks, Taka, and I appreciate you having me on to demo application authoring and service delivery in VRA 7. But first, what I wanted to do is talk about some of the announcements we made at VMworld in Barcelona this year with the launch of vRealize Automation 7. Several great innovative features included in this launch, or included in 7.0, that we've just received a tremendous amount of excellent feedback on. So real quick, where we're going to start, some of these spotlight features, I like to call them, is the advanced capabilities that come as part of the unified blueprint. And in this case, this is the piece I'm going to demo momentarily. But the unified canvas allows our customers to very naturally deliver new services in a drag and drop motion, whether that service is a traditional operating system like a Windows or Linux machine, or something more advanced, or even software authoring components, and that's exactly what I'll be demoing, or even networking services or anything, the X as a service components, drag and drop right onto this canvas, and I'll show you a lot of that. That's really the centerpiece of VRA7 and its capabilities. Just completely changed the way we go to market with with how we author and deliver net new services as an enterprise. So lots of really great things to show there momentarily. The other thing is the integration with NSX has come a long way and is better than ever before. And again, the idea with NSX integration is it needs to just be a natural motion, a natural integration point. Whether it's a single machine blueprint or a multi-machine blueprint, we no longer distinguish the two. Networking and network or application-centric networking needs to be just a very normal, natural part of that overall service. So drag and drop networking components right onto that canvas. And again, I'll dig a little bit deeper on top around that. But a couple of spotlight features that I'm not going to cover in the demo, I just definitely want to point out. The enterprise extensibility component called the event broker under the lifecycle extensibility umbrella. This is how we are going to be extending VRA 7.0 in a very new, very modern, but also a very key way of how we take VRA 7 and extend it into the overall ecosystem and make VRA 7 a core part of that. It's not just about what we're going to deliver through point and click out of the box. It's about what can we do into the broader ecosystem so that when I'm building an application and I've got external dependencies or external components I want to integrate into, EBS, or the event broker, is going to be critical in doing that. And extensibility plays a large role in any enterprise rollout of VRA 7. So look forward to reading or hearing or learning more about EBS and understanding what it can do for your business or your enterprise. And then finally, the implementation of VRA also drastically differs. One of the pain points of getting to this point and getting to all the goodness I'm about to show you is getting there from an installation and deployment perspective. So not only have we drastically reduced the footprint, but we've also completely automated that entire deployment process. So inventory-based wizard walks you through it, and whether it's monolithic in a single small POC type environment or a distributed enterprise production-ready environment, the wizard handles all the installation and all the configuration of those components, really pushing that time to value message and showing you how quickly we can get to a point to where I'm going to be authoring applications. So many great things. There'll be a lot of great content on all of these components coming out. However, I'm going to focus specifically on the app authoring component. So some of the features of the converged blueprint and the canvas that I've mentioned that we'll be demoing momentarily is, first of all, it's a unified canvas. Regardless, as I mentioned, regardless of what we're going to author, what we're going to drag and drop, whether it's networking, any operating system across any of the platforms we support, and including application authoring and consuming our local build repositories into building applications dynamically, and then, of course, integrated networking and security. It's one unified canvas. And the ability to consume all of this infrastructure and all of these software services through this unified canvas is really going to help me get to understand the benefits of doing something like this and taking automation beyond just infrastructure, but taking automation into the application layer, into the networking layer, and consuming overall through extensibility the entire ecosystem. It all centers onto this centralized converged canvas, the CBP as we call it, and it gives you a single point of management and creation of all your services within your environment. And to help you get started as quickly as possible, post-implementation, using the implementation wizard and even the quick start logic configuration wizards, one of the things we wanted to do is allow you to quickly get started in using and getting comfortable with the CBP. And so what we're doing is actually including out-of-the-box content that you can install using the cloud client directly from the appliance. We're also publishing a growing number of use cases, which are single machine and multi-machine components with all of their dependencies and all the logic built right into it via the Solutions Exchange. And how and why this is possible is that we are also introducing the ability to export and import all blueprints, any blueprint, regardless of the service that's running on it, as a YAML document directly from your portal. So you could you could export in YAML. You could make changes to that YAML document in plain text, and then you could re-import that into your same environment as a versioned copy of that additional application or the original application. Or you could even take that YAML and send it to a peer, send it to an entirely disparate VRA environment. This is a significant part, a huge ask from our customers, and very excited about giving that, adding that ability into the cloud client as part of VRA 7.0. But back to the out-of-the-box content, that will also enable you to build whatever VMware is put out there or consume whatever VMware is put out there into your own VRA environment. And what I would imagine is that we're going to see a large community come out of this, be spun out of the YAML trade, so that we can say, hey, look, I've built this multi-tier application with all these different components. You should import it into your environment and check it out. And you make some edits to the YAML doc, import it, and voila, you have an exact copy of at least the wireframe copy of that multi-tier or multi-machine blueprint or whatever it is. So really excited about this. It's going to help you consume external blueprints much faster. We're seeing a lot of really great use cases, as for example, incorporating Git into this and constantly being able to import the latest YAML of any application you support in your enterprise, consume it within the CBP, and publish out the latest blueprint. So look for a lot more information around this. The out-of-the-box content will ship with the appliance, but also the Solutions Exchange will start building up a library of its own content. And of course, the community is going to help you get started as well. And a little bit more about that blueprint as code, those YAML documents. This is going to really change the way we consume, use, and trade blueprints from across the environment, or either our own environment across tenants, and as I mentioned, across disparate implementations of VRA. So essentially, you just build your blueprint, and using the cloud client, you connect into the VRA environment, and with a few plain text commands, you could actually start listing the inventory and then exporting and importing applications. They're exported as zip files. You could edit them in plain text, and then again import them as a net new application with all of its components intact, or put them out there to be consumed by another environment. This also addresses one of the big challenges we had today, is getting all this work we put into a blueprint and actually moving it across tenants, across environments even, very quickly. So again, excited about Blueprint as code, and you can see we'll be doing a significant amount of investment into this, and eventually moving into formats like TOGAF and being able to standardize on a single platform for trading blueprints. Okay, and finally, before I jump into the demo, just some of the feedback we received from the couple of the beta cycles we've had have just really demonstrate some of the values of these spotlight features, including and definitely including the application authoring component and the converged blueprint, but also extending into the broader components and the other innovations we've added into VRA 7. So as I jump into the demo, please keep your questions coming, and we're going to try to continue to answer those throughout the demo. And of course, after the demo, we'll have some time to answer some more questions. But without further ado, let's get to the fun stuff and jump right into that demo. All right, and so in this demo, I'm going to jump directly into the Design tab, the Designer, where I'm going to build a multi-tier application and show you some of the features and highlights of the Converge blueprint and bringing everything onto this unified canvas. Keep your questions coming. We will do our best to answer all the questions as I go on, and hopefully you'll see some of the value as we jump into this.
All right, so here we are in vRealize Automation login screen, and as you can see, the identity management solution brings with it custom branding, and here we have the ability to brand the backdrop as well as the logos and such. I'm going to log right into here with my test user, who is an admin and a software architect and has got all the roles. At first glimpse, the UI looks pretty much the same or very similar, at least if you are a current 6.x or 6.2 user. And for the sake of time, I'm going to jump right into my design tab. Now the design tab is a new tab, and all infrastructure, software, X as a service design has all converged into this one design tab. Here on the left, you see we have blueprints. We have X as a service designer, previously called ASD, and then we have our software components. So the use case here is going to be building a multi-tier application that has a two-node web tier, a single-node database tier, with the appropriate security controls, the appropriate network, and then of course the software components that make up the WordPress app. There's a bunch of different ways to do this, and I'm gonna show you a couple of those options. But before I consume any software, I actually have to go and define what that software is. And to do that, we click on the software components. And here we can see that I've pre-created a bunch of different software components, and the ones I'm really interested in is the Apache and then MySQL pieces. So here, to create a new software component, I'm going to hit New. And as you can see, New SF 1.0. I'm going to name it. It automatically builds an identifier, and we typically want to have a pretty good description, so anybody who's consuming the software can go in and see exactly what they're going to drag and drop. The container gives me an option to actually bind this software component to a parent component so that I can't drag and drop new software 1.0 to a database if it's not a database script. If it's, in the case of WordPress, if it's a WordPress installer script, I'm going to have to bind that to Apache. So I can do that to lock down how and when and where I can use a particular software component. Now I can take that a step further and I can say I want to bind it to a platform. So let's just say I have blueprints that exist today that are designed for Amazon. I could actually bind this component to an Amazon-based Windows box or a Linux box and say you can only use this component in Windows in Amazon. And certainly it automatically puts all that logic together. You just have to select that Amazon machine from in here. But in this case, let's just say this is an install script that I want to put on top of Apache, or I can just put it at the primary container if I don't want to lock it down. But here we're just going to say Apache. So I'm going to hit Next. The properties dialog allows me, or the properties design allows me to create properties that I can actually bind from within an installer script. So for example, if I want to create a property called DB port, and I want my users to be able to actually select a custom DB port. And here we can say select, a DB port. And instead of using the standard MySQL 1433, I want the users to be able to override that if they want. So I can actually go in here, I can change, we'll just keep it as a string, I can change that value. We're just going to make that 1433 for the sake of demo. And I'm going to say allow override. And I also want to say that this is required. So if I have a value defined, I don't have to make it required because that will just pass the default value. But if I want to put in a value which is the default value, require it to be passed into the property, but also allow the override, this is simply what that would look like. So I'm going to hit the value of 1433, and let's just say that's the only property I want the user to be able to customize. But other properties are going to include things like IP addresses. Now when I build my database tier, I want to be able to understand what IP, if this is a DHCP or statically assigned or whatever it is, regardless, I need to know that IP address so that when I build the web tier, I'm consuming the IP address when I'm pointing to the database. Same goes for the database port. So I'm going to pass this information over during build time. So another property here would be IP address. Then I'm going to actually define my actions. And this is what builds the application at various stages. So install, config, start, and uninstall. The script types we support, bash, command, PowerShell, will basically get you to where you need to be to build just about any modern app out there, or even legacy app. So you're going to create a script at the install stage, and you're going to click here to edit, and you're going to build in that script. The other thing I want to know, or I want to be able to do, is take that property, which I now made a required input, but also the option to pass over default, and I want to bring that into the script. And so let's just say this is a long multi-page script, and as I'm building this web front end, I want it to bind the database port that was also pulled from the database dynamically. So I could bring this right in here into the script and be able to consume that, either whether or not it was a user provided or static or anything like that. So next, let's just say I filled all this out. So next I'm going to complete it, save it, publish it, and be able to move on to actually authoring that application. But again, I'm going to use these WordPress ones that we've already created. So to start putting the service together, I'm going to jump over into Blueprint. And I'm going to create a new blueprint. No longer are we talking about single tier or multi-tier. This is all just authoring. This is all, whether it's infrastructure as a service, platform, networks, or X as a service, they're going to all be consumed and converged into this new blueprint, although they can be created in some of these other some of the other windows like software components and X as a service. So here I'm going to call this my new app 3.0. A descriptor is always nice. I'm going to give it an archive so that if I have a lease maximum and it expires, that I'll hang on to the bits until I meet the archive date. I could also determine here whether or not I want to use NSX, and of course, why wouldn't you? The power of NSX in VRA7 is incredible, and there's just a lot to gain. Now, you don't have to use NSX, but some of the features that we can add dynamically, like dynamic load balancing, dynamic routing, and on-demand, both of those things, is quite impressive. So I'm choosing yes, I am going to use NSX, and I've got the option also to isolate this entire thing. So in the case that I'm building a pod and I want to deploy multiple of these, and I want them to be completely isolated from one another while maintaining internal IPs. That's a very common use case. I can go ahead and isolate that app. Just block it from the world and allow just the machines internally to communicate with each other. These little info pop-ups help us out pretty nicely. So I'm going to hit OK. I don't have any other properties I want to use at this point. And here we have our unified canvas. This is a drag and drop canvas. On the left, I've got my categories of all the components. On the right is my grid canvas that I can drag and drop to. So as I mentioned, we've got our machine types. Every platform supported out of the box is available down here. So you see some Amazon, some Zen, Hyper-V, KVM, and of course OpenStack, vCloud Air, and our favorite vSphere. And we want to be able to build machines based on these canvases. So a single canvas or a single blueprint supports a single platform type, but the software components themselves can actually be dragged and dropped as long as they're not bound to a particular platform, dragged and dropped across all platforms. So here I'm going to drag and drop my vSphere machine, and I can start configuring that vSphere machine. So I can call this web, define any of these other properties I want. The build information looks very similar to the way we do it today. The action, I want to do a link clone for the sake of speed. And then I can go through and configure all these things. We've got our machine resources, storage being consumed based on the template I choose, and then networking and security. And also note that right now networking and security is not available, and that's because I have not dragged anything into the canvas yet. But I had also mentioned that in my environment, somebody else builds the base machines for me. So as an app author, I don't want to be building base machines and bringing in things from my endpoints. I just want to consume things that are existing. And that is quite possible now. So I'm going to actually kill that component. And rather than building each component for the sake of building out this application, I'm going to jump down here to my blueprints. My IaaS admins have already created all these blueprints that I can consume. And two of these were my hardened WordPress web and WordPress DB. So I'm going to just actually consume the work that somebody else has already done, which makes things pretty great and efficient for me. At this point, I don't have to worry about the individual logic that goes behind this CentOS vSphere machine. It's just drag and drop. Now, these are blanks, meaning they don't have their own network, but they could have. They don't have any software, but they could have. But for the sake of allowing any app author to go and drag and drop components, the IaaS authors decided to just keep these blank, which works out nicely. Now, so I have my WordPress web, WordPress DB, and next thing I want to do is bring in a network. The way I'm going to build this network is actually through NSX. So the architecture here is we're going to assume that this multi-tier application is going to go into the DMZ, and I want the inside IPs to be private NATed IPs, while the external interface is uplinked into a provider logical router provided by NSX, and that will sit or be linked into the DMZ. And we can do that quite easily. My on-demand NAT is a drag and drop network that I can bring right here onto this canvas. I'm going to name this whatever I want. We'll call this my WordPress NAT. Just give it a number. The parent network profile, which could have been created by vAdmins or a network administrator, depending on whatever it is. That is the network profile available from within VRA that is bound to those external components. I have a single NAT one-to-one policy, so I'm just going to consume that. And that essentially covers my networking. The other thing I want to do is bring in some of the security policies. So again, in my environment, we have a requirement to lock down each machine and only allow the appropriate rights. Fortunately for me, I've got a security team that's pre-created some of these policies. So I've got, for example, so here's an existing security policy. Again, I'm pulling this from NSX inventory. And for my DB tier for development, I have a policy that allows only certain ports through. And again, for my web tier, same idea. I only want to allow 80 and 443 through. I'm going to hit OK, and then take a look at this. So at this point, I've got a NAT network. I've got my security policies that's going to create this bubble around each one of these components. And what I want to do last is actually bind the component to these, bind the OS to these components. So now when I go to networks, because I've dragged it and dropped it onto the canvas, I can click new and consume that NAT policy. I can go to security and consume the appropriate web tier. Okay, security policy. I'm also going to jump over to the database, and I'm going to do the same thing. From network, I want to create a NAT policy link, and security, my database policy. Okay, and that's what's going to look like. We're actually creating the links dynamically, and we're building this whole thing out as we go. The other thing I want to do now is actually create a load balancing policy, and I only want to do that for the web front end. So I'm going to come back over here and grab my on-demand load balancer. I'm going to call this LB, no, we'll call it WP just for the sake of consistency. The machine I want to load balance, the web tier, the NIC, which has now been bound to that internal NAT interface, and then even the VIP network that I want to create the VIP on. And in this case, it'll be the external NAT. Okay, I can create a static IP here if I wanted to, and then of course I can add the services that I want to load balance. So let's take another look at this. And we see we have a load balancer on our WordPress app, but at this point that WordPress app is only one single machine, so I'm going to create a minimum here of 2. That way I'll dynamically create, so just by doing that I'm clustering this WordPress front end, putting a load balancing policy in front of it, and automatically building 2 legs on that VIP. Okay. The other thing I want to make sure is that this machine, the web component, doesn't come up before the database component. So one thing I can do here is by dragging and dropping this dependency, I can do component level dependencies. And when I did that, you see this arrow here was created. Now I can do that at the component, say build all of database first and then start building WordPress, or I can say do this at the application level, meaning build these 2 components from an OS perspective together, doesn't matter, but create the software dependencies from within the software layer, which is I'm going to do next. So at this point we've got basically IaaS, right? We haven't done any app authoring, but we have our networks, our load balancers, our security groups, and if I save and finish this and publish it, this is exactly what that deployment is going to look like. I'll have 2 web front ends and a database backend. But now let's get to the cooler stuff, more cool stuff. For my software components list, I want to go and drag and drop those software components that I created earlier. Anything you build automatically is added to this list. So let's just say I want to build out my database first. So let's go to that SQL database. I'm going to drag it and drop it on here. And the other thing I want to do is drag and drop the config. Now that config, as you can see, I cannot drag it and drop it onto the vSphere machine because it has a database parent dependency. So if I bring it over the database parent, all of a sudden that works. And I could rename it, add properties, etc. as needed. Same thing goes with Apache. So for Apache, that has a machine dependency, which works well. PHP has a machine dependency, so that works well. And then my WordPress installer script actually has an Apache dependency, so same idea. I can't drag it over PHP, I can drag it over there. So what this will result in is Apache being built before the WordPress install, and then PHP being built either in parallel, or I can build a dependency here so I can bind it to that parent object. And I definitely don't want Apache to come up before the database, or the WordPress install to come up before the database, so I could also create a sub-dependency. But since I have this parent dependency here, essentially what I'm going to do here is make sure that WordPress DB gets built first, and then I'll start this whole stack. Again, the other option is to allow them to both be built in parallel and then put the dependency down in the application. So that's essentially it. At this point, I've got a multi-tier application. I've got my NAT network that I dragged and dropped, my load balancer to a set of clustered load balanced web front ends. And once the machines are up, they're going to install Apache, do the WordPress installer once the PHP is done, and then do all of that after the SQL config has been completed. And all of that is wrapped into 2 existing security group policies that protect each one of these tiers. I'm going to hit save and finish, or just finish, and then I can go and take this app, publish it, and do whatever I want to do with it to eventually make it available to the catalog through entitlements. All right. Thank you very much. I hope you enjoyed that demo. Look for many more of these that are going to be available out in the community and through VMware.com and various other sources. And really appreciate your time. We're going to stick around and answer some more questions as we go through closing. If you do have any questions, please keep them coming, and we'll do the best to answer all of them. All right, Taka, back to you.
Thanks, Chad. Thanks for the awesome demonstration. Okay, so let's take a step back and do a quick recap. We understand that increasing demand for new and updated applications means shorter release cycles and higher risk. That's why enterprise must accelerate the entire IT service lifecycle and associated ecosystem components, not only infrastructure services, but also the application deployment and the downstream release processes. So VMware offers a number of cloud management solutions that can help you continue along your enterprise hybrid cloud journey, building on virtualization and private IaaS. So vCloud Suite and vRealize Suite are cloud management platform solutions that extend self-service provisioning from IaaS to application and middleware services. And we've shown you how to deploy multi-tier applications with the new unified blueprint model. This approach can help your company take one big step closer to unified hybrid cloud, DevOps, and continuous application delivery, enterprise-wide. So why choose VMware CMP to accelerate your application deployments? Well, who else besides VMware can claim they can help you automate everything in the software-defined data center and at scale? The software-defined data center architecture provides the ability to build, operate, and automate infrastructure and application delivery for traditional and new application types across private, public, and hybrid infrastructures in just minutes. VMware CMP is based on this underlying architecture and offers the most complete solution, including day 1 and day 2 management capabilities. Okay, so where do you begin? You can start by first reading the Forrester Total Economic Impact Study to learn more about the potential benefits. Next, check out what our other customers have accomplished to better understand the potential end state. Then you can go back and reassess your application deployment and cloud objectives. Once this becomes clear, we can help you understand the technology gaps and the steps to get there. You can engage your nearest VMware rep, and we can help build a roadmap together. Well, we hope this webcast was helpful, and we'd like to thank you for spending time with us today. If you have any more questions, please stay on, and we'll be here to take some more questions. If not, have a great day.